some people who may not know Orkestra or may not know MPSTOR some background as to what exactly Orkestra is. It is a piece of software with 5 major components. The first component is what we call Orkestra VSA. That's a tenant-based provisioning tool. So that's a virtual machine that sits inside your tenant space, and it allows you to provision and have all the storage functionality within a tenant space. So within your own tenant space, you can have your own virtual storage array. And that tool by itself, if you sit down and do a VSA to VSA type configuration, could be used for disaster recovery. However, we're not going to look at that particular use case today. The next tool is the Orkestra HCS. So this is a complete OpenStack distribution, a piece of software with OpenStack in it, with all of MPSTOR compute storage and networking in it, and with that tool we can stand up and create an OpenStack Cloud. The SDS is a standalone tool within a data center. If there was a lot of storage to be provisioned to a lot of different consumers, and by that I mean if your volumes that you need to provision to your host runs into the 50, 100, 200, thousands, you need a system. You need a very efficient system of provisioning and tracking all those volumes. Today we're not going to look at that either. We're really going to focus on Orkestra in a DR configuration. The VBS is an in-band component that sits on all compute nodes of an Orkestra Cloud, and it serves as the termination point, and it serves as the main tool that you use in building scale-out volumes across multiple storage arrays. And then finally, the Orkestra SAM module, which is the storage array management module. That's a standalone a component to allow you to build a storage array from standard hardware, and that has all of the features that you'd want in it, all of the creating RAID, all of the management of different fabrics, and creating block file, object, and all of the volume services that goes with that. So that's a very brief overview of what Orkestra is. And when you deploy all of that within a data center, you have an architecture which looks something like this. 4 core components of it. All the management of storage array providers across multiple protocols and fabrics. This in-band termination of all of the storage. The various delivery tools up to the various consumers. And today we're going to be looking at principally the consumer that we're interested in is the virtual machine, because that's what we're going to be showing how to do in the DR site. And then finally, the out-of-band control plane. So looking at each of those blocks in detail, the first layer of Orkestra, the storage array management, will take storage providers, disks of different media types, SSDs, SAS, SATA, whatever, and create a storage that can be provisioned up to these consumers over a block or file using sys or NFS or an object store. And today we're actually going to use Orkestra in a configuration to create an object store that we can do the disaster copy to, the backup of our virtual machine to the object store, and then we're going to recover from that object store. In between all of that provider layer and the consumers is the termination layer of those virtual machines. MPSTOR has various delivery tools such as the virtual storage array, the SDS, software-defined storage controller, or the storage array management to that provider layer or that consumer layer. So very, very quickly, last slide before we get into DR. What is in that Orkestra stack? Well, there's the storage array management, which has all of the management of the different fibers, fiber SAS, fabrics I should say, fiber SAS, 10 gig E, 40 gig E, all of the volume functions, snapshot, tin provisioning, replication, backup to the cloud. We're going to be principally looking at that function today, backup to the cloud, to implement our disaster recovery, as well as the software-defined storage module for provisioning all of the various storage providers. We won't focus on that today. And then the various virtualization module, the Openstack module with all of the associated dashboards. So that's what's in Orkestra HCS in the general sense. And that Orkestra product can be used then in to build a hyper-converged all-in-one storage appliance. That's one use case. Another one is to build a very large scale-out object block or file storage, or to build a cloud, a public or private cloud, and to scale it out by adding multiple nodes. So that's a background of what Orkestra is. So we now need to look at in more detail exactly what we mean by how we can use those tools to implement disaster recovery. So simply put, if we consider that in my cloud I have a virtual machine that's running, and I really want to have that virtual machine, a copy of that virtual machine, over in the disaster recovery site. So there are two ways of doing that with Orkestra. So one way is to copy it literally from one cloud to another cloud, and there are different ways you can achieve that copy. Or you could copy it to a public cloud using, and this copy would be done using an S3 type backup, and then do a restore function to your disaster recovery site. So there are two paths you can use, or two ways you can implement this. Directly copy it, or copy it to a public cloud, and then copy it in when you want to achieve your DR recovery. Now there are obviously advantages and disadvantages from one to the other. If you choose this option here, a copy from your own cloud to your DR site, then your data is in an object storage here. Your virtual machine is in an object storage here, so the restore time is very short. But you do need to have this object store running. Going through a third-party cloud has some advantages, but has a longer restore time. So what do we mean by copying a VM? Well, copying a VM is a virtual machine is a set of data once it has been flushed from memory to disk. So when we mean copying a VM, it means copying a point in time, a particular point in time, or a snapshot, if you like, of your VM from A to B. Very important, that point in time copy must be coherent. Okay? And by that I mean that if I restart the image, it will be functional, and it will be functional from the time T0 when we said we were making that point in time copy. So that's what we mean by copying a VM. It's not just copying the data and the data is changing. We have to very, very specifically take a snapshot of the data, and that data has to be coherent, copy it, restore it back to another virtual machine, and then when we do that, hopefully the restored image or the restored virtual machine is going to be a coherent and true snapshot of the point in time copy that we made. So the steps in copying a VM are going to be get the VM into a coherent state. So to do that you have to do a little micro pause, flush it all to disk, snapshot the VM, and we're making the assumption here that the virtual machine is maps to a volume. And that means that when we launch our VM in OpenStack, we're going to pick a particular option called boot from volume. Step 3, you got to copy that snapshot to the DR site, and we have to restore that copy to a VM volume, and then restart the VM on the DR site. So if we look at that, what we're trying to achieve, all those different steps, the first step is, in today's demonstration, what we're going to show is very, very quickly how to set up an object store on that remote site. Now we've slightly cheated in one way, in that a lot of the setup we've pre-set up some of that, but we're going to go through the principal steps or the main steps in setting up that object store on the DR site. We're then going to go back to our MyCloud, our cloud site, and we're going to create a volume. And in that volume, we're going to put a virtual machine. This is equivalent to using the Openstack function called boot from volume. And it's very important that we use the boot from volume approach, because once we have the virtual machine in a volume, there are many different volume functions that a storage array can apply to that volume. A storage array, for example, can snapshot a volume. It can back it up to an object store. That's exactly what we're going to be doing. It can also replicate the volume. So there are many features that you can apply to volumes. So it's important that you encapsulate your virtual machine in that volume. So step 3, we're going to use the Orkestra backup tool, okay, to back up that volume to an object store and stick it into a particular bucket. And that backup will be a backup of that virtual machine at T0. Now, I think it's important to note here that the use cases that people are interested in is, hey, I've backed up my virtual machine at T0, but what happens at T0 plus 1 day? Well, that's quite simple. The backup tool will be set on a schedule to do that same process every 12 hours or every day or every Friday, whatever you set the schedule to be. So we don't have to worry about doing this. This process can be automated. The next thing that you need to be concerned about is, my virtual machine is, so many gigabytes, and I have attached to it, so many hundreds of gigabytes or terabytes of storage. So does that mean every time that I do a backup, I have to copy all that data across the network? Well, the answer is you shouldn't, but the first time you do it, you will. So the very first time when we do the backup on the object store, there's nothing on the object store. So we're obliged to copy everything related to that volume over to the remote site. At the next copy, we simply do a differential copy of any of the block ranges that have changed. So we probably might, if only 10% of our VM is changed between one backup and the next backup will only copy 10% of the data. So the Orkestra SAM backup to the object store is a differential block backup. And during the presentation, we're going to have a look at exactly how that's achieved. The final step is if MyCloud somehow becomes out of action or falls apart, falls down or whatever, then we want to be able to restore the volume back into, we want to restore the virtual machine into a new volume. Now we are back to exactly the same state. We've created a volume on our own cloud. 2, we have copied a virtual machine into it. We booted it, we're running it. We then back that up through the backup tool to the remote object store. If there's a problem with our MyCloud, we can then restore out of that bucket into the virtual machine. Now, it does not matter whether you're using an Orkestra SAM as the way to implement the object store. This could quite easily be an Amazon AWS system here. We're not going to do that today. We're just going to use Orkestra Swift Object Store. What is specific is that the restore function, because it's the restore function which understands the format of the bucket that you've backed up to. So whilst the bucket can be in AWS, the restore function needs to be in your DR site. But that restore function can work equally well with a local object store or a remote object store. All you need to do is put in the access details and credentials. Okay, so we're going to have a look now and at all of the steps actually using the Orkestra tool. So step one is going to be creating the Swift storage. So if you just give me 2 seconds here while I find it on my machine. Oh, actually, maybe it's in here, is it? Yeah, it is. So, okay, so on now the various steps of how to create the object store. So to create an object store, you need to have a bunch of disks. So in our setup, we've already set up a number of disks, but we're going to add in the last remaining disk into the object store. And once we've done that, every time we create a resource, we export it to the Swift service. And once we have created all of our storage assets or storage resources, we'll have a look at them in a second now. We've just done the last one. We will be left with all of the resources that we need to build the object store. So I'm just going to pause it here. So here I have a whole bunch of disks that I've created on my Orkestra SAM module, and those Orkestra those disks I'm now going to take and I'm going to add them into my object store. Okay, and I'll show you how we achieve that. So I simply hit my setup button, and again I'll just pause this here. When you set up Orkestra, you can choose whatever functions you want to run on that particular node. You could decide I just want to run it as an object store. You could decide I just, in case I don't need object storage, and I can just export all my volumes over block or files, CIFS, NFS, etc. over any fabric. Or you could say I want the Swift service, the object store service. Or you may decide that you want to run other services, such as an Openstack Cloud controller or an SDS controller or a compute function. So you can choose all of those different functions, or just choose one. In this particular case, we're just choosing Swift. And I'm going to choose Swift in the particular configuration called all-in-one. So I set up all of my details of my Swift object storage. So I'm going to create just a single username called root system with a standard password. I'm going to use 2 copies. I'm going to keep 2 copies of my data, and I'm going to create 3 zones. So they're the very high level way you define an object store, and we'll see practically now how I put all my storage resources into those. So here I have all of the storage resources that we saw on our previous screen that I have exported to my object store. And very simply, I'm just going to choose all of these and select all these disks. These are all the disks that have been exported to Swift, and I'm going to put them into different zones. So we said that we were going to create 2 copies in 3 zones. So here I just pick and select which zone I want to put my drives into, and that's it. And that's the IP address that all of those drives are coming from. Now, previously, when we set up this object storage, we said we were going to set up an all-in-one unit. So it's quite normal that all of the resources come from just this node. If we said we were going to set up multi-node, then we could have many downstream storage nodes all being connected back to one or more Swift proxies, and then on top of that we could have deployed a load balancer. So this is a fairly simple configuration, and as you can see, the setup is very quick. So that's it. We've now set up a Swift object store. It's quite simple, quite painless, and installs very, very quickly. So once we hit the start button, it will then start assembling all the disks, building the rings, doing all that all of the setup, and that can take building the rings, and we've used small volumes for this, but if you're building petabytes or hundreds of terabytes, this can take hours to complete. So we just let this roll on here. So eventually the build will be completed, and when it's 100% done, at that stage we're ready to move on to the next stage, and this message will be displayed up here. Once we have our Swift object store up and running, a very good thing is to really just go and check, make sure that that it's working. So I'm going to use here just a tool called Cloudberry. I'm now going to just put into that the exact same credentials I used when I was building the object storage, system.root, the same API key, and the URL of the object storage. Test connection, works fine. Okay, so that's just good practice that once I've done it, then just be certain that it's all working. I copied a file over there, so I'll just just verify that I can actually see the file. So I can load the file, see the file. So that's fine. I now have a working object storage, so I can now back up to that. Okay. So the next step is to create a volume on my cloud site. So I'm actually just going to pause this here for a second, and I'm just going to show everybody with respect to our with respect to what we're trying to do, where we are. So if we go back to our disaster recovery plan that we showed at the very beginning, what we've now done is this: we've now created an object store out on our DR site and tested that we can upload, download files to it. So this object store is now working. So we're now going to come back here, and we're just going to use OpenStack in a pretty standard way, and we're going to create a volume here, and we're going to put into that volume a Windows virtual machine image and just boot it. Okay, so we're going to go back now to my cloud site, and we're just going to get a virtual machine up and running, one that we're going to then use for our disaster recovery plan. So let me just go back to our so we can roll this on. So and this is a standard OpenStack dashboard. Okay, so I'm going to create a volume, and I'm going to choose a Windows XP volume. I'm going to set its size, and I'm going to create that volume. So this is a particular function of OpenStack which says when you create a volume, you can create that volume and put into it the image that you are going to boot as a virtual machine. So now I've made a mapping or a binding of my volume to my virtual machine. So I do have to copy in the image, so that's going to take that takes a little while. But the value of doing that is that once I've created the volume, once I've dropped my virtual machine image into it, I now have all of the Orkestra storage array management tools that I have all the Orkestra storage array management tools that I can then apply to that. And we can create as many virtual machines, as many volumes as we like. This system, will scale. In fact, it's probably a much more scalable way of implementing a cloud using boot from volume within OpenStack than actually booting from the more traditional way of booting from a glance volume. However, all the principles that we're discussing here can be equally applied to booting from volume or booting from a glance service. The only problem there is that you need to actually So now we're going to launch the virtual machine. So we're now going to launch it, and we're going to pick the option of boot from a volume, and we're going to select the volume that we created. Set up all of the other functions, such as to decide what network it's going to be in, and the access and security, and a few last details such as the instance name. So once we've completed that, we're now going to launch our virtual machine in our OpenStack Cloud, and that virtual machine is going to be within a in a volume. We're then going to take that volume and we're going to copy it. We're going to take a snapshot of it and copy it over to our. We're going to copy it to our remote site. So this step now is standard OpenStack step of building it, spawning it, and getting the virtual machine up and running. So now we have our virtual machine up and running. If we just log into the console, we can see we have our virtual machine there available. So that's the step of on our cloud, getting our virtual machine up running. We're now going to move on to the next step of backing it up and then finally restoring it on the remote cloud. Okay. Let's just check everything's okay. Everything is fine. So we now have a running VM. Now, over on the DR site, okay, sorry, on your cloud site, we're now going to go through the steps of actually backing up that volume to an object store. So we've already set up the object storage in the previous step. We're now going to back up the virtual machine, the volume, to that virtual machine. So I'll put in the URL, all the details of exactly as I did with the Cloudberry tool. I'm going to put in the same credentials. If we have multiple users, then obviously you need to create as many users as we have tenant spaces, and we give it a particular bucket name, okay, and pick the volume that we have. Now, this step, what this step does is it schedules a snapshot, and internally we'll put the VM into a known state, and then we'll schedule the snapshot. That snapshot takes place about two minutes later. So if I then go back in and I log in using standard Swift browser on the backup site, I can see that I have a bucket and in my Windows 4DR, and I'm just going to pause it here. So here I have all of these objects within that bucket, that Windows 4DR bucket, and this on the remote site. And each one of these blobs here in that bucket is a chunk of our virtual machine, and that is configurable, but usually you want to set that chunk at something like 2 megs. So every time we run this backup, it will look at every 2 meg chunk of the virtual machine and decide if that chunk has changed with respect to the last one. And it does that simply by every time it looks at a 2 meg chunk of your virtual machine, which is in your volume, it calculates a SHA. It then looks at the equivalent chunk on your object store, and as we said, that could be an AWS, or it could be, another Swift, or it could be an Orkestra Swift. It doesn't make any difference. But this format, you can see your virtual machine here isn't in a single file. It's actually made up of lots and lots and lots of small 2 meg files, or whatever chunk size you configured, and every one of them will only get updated when and if you're at the next snapshot, and it goes to check the SHA of your backup. Just roll this on again. Okay, now the next step is I need to go to my disaster recovery site. Okay, so I need to log into my disaster recovery site, and I'm going to create a volume in my disaster recovery site. So this, as you can see here, I just snap here, this is my disaster recovery site and the special storage group that I've created called Disaster Recovery Local. And what I need to do is I need to create a volume which is equal to or greater than the previous one. Now, just to illustrate a point, okay, there's a small problem here with I need to give it a name. I'm going to launch an instance, right, from that volume. Now, the reason I'm doing that is I'm just going to show you that it won't work. I mean, I've just created a volume. I'm going to try and launch it. And, of course, there's nothing in that volume, so there's no virtual machine, so we won't be able to boot. But just to illustrate the point, I'm actually going to go and do that. So this is on my remote site. So I'm going to boot from volume. I'm going to pick my Windows for DR volume, and of course it won't work because I haven't actually restored anything into it. But this is on my remote site. So my remote site is running Orkestra as well. So the tenant administrator sees exactly the same thing on both sides. He sees OpenStack Cloud running on his cloud site, and then on his disaster recovery site, he sees exactly the same tools. So now if I click on my Windows Restore, if I look at the console, we can see that the console is telling us, guys, nothing worked. So boot failed, could not read the boot disk. And that's normal because I may have created the resource for the Windows machine, but I don't actually have anything up and running. Now I'm going to run my restore operation. Okay, so I'm going to select Swift. My URL is the URL of my disaster recovery site. Again, I need to use all the same things. But I do need to get the right bucket, the right alias. So I need to go back to my Swift browser of my object store and actually pull out of it the alias name and put that in. So I'm now going to restore from the object storage the backup that I took from my VM. Okay, so I'm going to restore into that volume. And that's it. Now if I go back, and this time around, if I try to launch my Windows volume, now it will boot, and this time it will actually boot correctly. So now if I log into my console, instead of getting can't boot, it will say, there you go, here's your Windows machine up and running. And this is an exact copy. It is a binary copy of the remote machine. Now, obviously, there are some things that you need to, if you're backing up many multiple machines, you know, when you restore them, they're not all going to have the same IP address, but if you're using DHCP on both sides, then they'll all just boot up normally. And if those VMs need to talk to one another, then you need to make sure that you're using names instead of, you know, hard-coded IP addresses. So I think I can pause it there. If we now go back to what we started off with, okay, if we now go back and to recap the steps that we've done, what we've shown is we have if we now go back and we look at the various things we've done, we have done created my cloud, created the volume, put a virtual machine into that volume. We have backed that up to the remote object store. That could have been Amazon AWS, or it could have been an object store provided by MPSTOR. It doesn't really make any difference, but the good advantage here of doing it into an Orkestra SAM object store is that actually is in the same data center as the remote site, so the recovery time is much faster. We've backed up the virtual machine at a point in time. So we backed up a snapshot. So when the back off kicks off, the first thing it does is it quiesces this machine, creates a snapshot, and then starts the backup, and then releases this virtual machine. So the virtual machine is free to continue on. Then the last step was we created a volume on our disaster recovery site. We tried to boot it, but it wouldn't work because there's effectively nothing in it. So we then restored that volume. We restored the virtual machine from the object store to our volume, and now we were able to log in and run the machine. So these are the steps we did. Create the Swift object storage. We did a Cloudberry test to make sure that our object storage was working. We launched the VM, and we chose boot from volume option. We then backed it up to the disaster recovery Swift site. We then checked the backup in the Swift. We created a volume in the DR site, and then we restored that object to the virtual machine volume, and then we were able to test the restored volume. So there are the steps that we've done. So it's perhaps a lot to try and remember. So this video is available online, but I think what we've clearly demonstrated is two sites, both running OpenStack. Orkestra can be used to back up a volume using object storage from one site to another, and then on the remote site restore that volume into an OpenStack volume and then launch it. And I think we leave it there.
Thank you very much, William.
I suppose, Mo, I should really just go back. Maybe if I could just give me one more second to go back to the the opening slide.
Mm-hmm.
Okay. And in the opening slide, we said that the goal was to copy a virtual machine from A to B, but a consistent, coherent copy. And that can be achieved through a number of ways. One way of doing it is the cloud backup tool, and we've shown you how the cloud backup tools work. Another way is to use CDP. That's replication, constantly replicating from A to B, or to use the virtual storage array within the tenant space. So there are numerous options, and they all have merits and pros and cons. But the one that probably has the most pros is the cloud backup, because periodically at a schedule that you determine, you can schedule when the snapshot is taken, and then only the differential will be backed up. The differential will be between the VM and its last snapshot. If you use replication, then every single time a block range changes, it will be constantly replicated to your remote site. So one has a lot more copies and the other one doesn't. So Mo, any questions from the audience?
Yes, so thank you William, for the presentation. I hope everybody enjoyed and got something out of the webinar today. There are a few questions. Please keep your questions coming. And after the webinar, we'll post the webinar onto a link that will email you so that you can review it at your own time. The first question, William, it goes back to these models of backing up or doing a disaster recovery of your cloud. In the case of an appliance, the same method applies, but which one of the methods would you recommend? Would it replication, VSA, or cloud backup? And this is really if you have an appliance based on the hyperconverged solution, how would you do it?
I think, as I said, probably the best implementation is to use the cloud backup tool. Using replication, continuous replication works on the principle of every single time there's a change in an LBA range, it gets replicated. So you wind up that the DR site is always lagging a little bit behind the original site, and that can pose problems for coherency. If on the other hand you take a snapshot of your volume and then replicate that, then you're effectively defaulting back to a cloud backup. So you might as well just use the cloud backup. There are variations of the cloud backup, which is backing up to an object store. But if you were to tunnel a VPN between the DR site and the MyCloud site, then you could you could equally back up to a folder, a remote folder on that remote site. But I think the cloud backup does have some specific advantages. And sorry I didn't prepare a grid on it, but I think an appliance based on Orkestra should probably use cloud backup. It'll get the most. It is guaranteed to get an accurate result in the end.
Okay, thank you. Another question: is it only a volume level or a group of volumes, as in a consistency group?
So the cloud backup. So if you have multiple volumes, then you're going to have a remote object store, whether that's an Amazon or you've built one using Orkestra. As long you can back up as many volumes as you like to that remote site, as long as that remote site has space. And remember, the amount of space you're going to need in your remote site is equal to basically the size of all of the virtual machines and the volumes that are attached to those virtual machines that you want to back up. In terms of, can you set up a backup operation and say, well, here I want to pick 20 volumes to back up at a particular moment in time? No. In today's implementation, you pick singly the volumes that you want to back up in today's example. However, and unfortunately the Orkestra suite is quite a large suite, so we can't really get through everything. But in Orkestra has a very nice feature, and maybe I can just show it here. I'm not sure I can show it here, but Orkestra, I can't. Orkestra has a very nice feature which allows you to apply a policy to volumes. So if I set up a policy on a volume which says, look, I do snapshotting, or I do replication, or I do backup, then all volumes created within that policy will obey the same rules. So if you wanted to have as standard your virtual machines backed up, then you would simply go to your SDS controller, create a policy, associate that policy with the you will use the the policy to impose the same backup strategy for all the volumes created within that group. Unfortunately, that's
William,
a very good question, but it would take another webinar to do, how to create policies.
I think we can go back to we can respond specifically to that question, but it's just as another to the question. A DB instance has log volume, index volume, and DB tables. We have to consider all in sync fashion. So that's the question. So that's
absolutely
that's the question where it comes from.
Yeah. Well, actually, that's a good question. Within the backup that we've shown here, right? There is no framework to do application level coherency and consistency. So within OpenStack, I can make a virtual machine consistent and coherent. But if you want to get all of the storage associated with that virtual machine, then you need to be running some consistency like VSS actually within your virtual machine to make sure that all of the storage gets. You need to be running VSS within your virtual machine to make sure that the attached volumes are themselves coherent and consistent.
Well, to add to that, there's just another question there, William, on the same snapshot, and I suppose would use VSS to maintain consistency on Windows machine. But how do you do that on other operating systems, such as a Linux operating system? Like how can you make sure that your data is consistent? And I think there are other tools to allow you to do that.
Yeah, actually, and you know what? In this particular implementation, making the VM consistent, right, is not the same. Making the VM consistent and all the attached storage consistent is not really the same as and I see somebody there suggesting some of the answers, is not really the same as making the actual application consistent. So it's a really good question. That's probably why we do these webinars, for other people to point out what's probably the obvious. But I don't think that we have a framework. We don't have a framework for doing application level consistency. Now, I saw a comment there popping up that there may be some Cinder APIs that we could use.
So just, I think we have time for one more question, William, and then I think we have emails of people that we can just respond, but we'll post this and they can find some of these answers on our blog soon. How about volume used by VM? So when you attach a VM, should these volumes be backed up in the same way you back up a volume, VM volume?
Yeah, absolutely. So so the whole point is that if it is really a volume backup and restore function, and Orkestra providing the object storage, the backup function, the restore function, the differential backup for anything that's changed. But once a VM gets booted from a volume, it is, as far as the backup and restore function is concerned, there is no difference. The VM or a VM attached to the VM, they're all just volumes. And obviously, at the very beginning of the webinar, we said, look, the trick is that you just can't back up a volume. You need to make sure it's in a consistent state. So I do take and I do agree that what we haven't shown today or talked about is how, at the application level within the virtual machine, we use services to make sure the volume is consistent.
Okay, so maybe William, one last thing to touch on is the fact that our SDS controller has some of those functionalities to allow for backing up and replicating those volumes automatically depending on the storage groups and compute groups that you've defined. So that's probably for another webinar, as you said.
Probably is, though hopefully I could very quickly just open up the SDS controller.
We have literally 1 minute, so.
Yeah, I have here. So if I open up the SDS controller, which obviously we haven't looked at in this particular But the SDS controller is a way of creating different compute groups, storage groups, and putting different resources and media tiers and all that good stuff into those different storage groups. But there's policies associated with them. Now this is actually the MPSTOR SDS controller, which is running cloud.mpstore.com. And if I edit that, we can see that, for example, if I wanted to set up a snapshot associated with a particular policy, I could do so. If I wanted to set up an IO throttle or a bandwidth throttle or whatever, I can create a policy and associate it with a group, and then once I've created a storage group, if I then, sorry, I need to go back here. If I then edit a storage group, I can, where's the policy here?
It's in policy.
Oops. Yeah, so here I can, when I create a storage group, I can associate a particular policy with it. And now, any time that that volume is created according to that policy, then all of the policy rules will be applied to that.
Okay. William,
and those,
thank you very much.
Okay.
I think we've just reached the end of the presentation. I hope everybody enjoyed the presentation. We'll make the link available, and we'll send you an email with where you can get access to the presentation slides and also the recording of the presentation. Thank you very much.